Once you can draw your unit circle, here's what the purpose of it is. This is where you're going to use it throughout all of trigonometry, and drawing it was kind of the foundation. Now you got to be able to interpret it, and it's pretty simple. Before I get too far into it, you may not know what cosine, sine, and tangent are, and you get into that when you learn the trig ratios. And you may not, even if you've seen those before, you may not know what secant, cosecant, and cotangent mean. Those might be new to you. They're the reciprocal functions, so basically secant, you just flip over cosine. Cosecant, you just flip over whatever you have for sine, and cotangent, you flip your tangent, and tangent is defined as sine over cosine, so when you flip that, cotangent is defined as cosine over sine. So all this will start to make sense when we look at numbers, but don't worry about what all these mean if you haven't learned this yet. Just know how to find your 6 trig ratios based on the ordered pairs that we've used and the degrees that we've used and the radians that we've used. And then you will learn what all this means even further as you get more into trig. So the key is all these ordered pairs that we created will represent the answers to a cosine, sine, or tangent type ratio. And so if someone was to ask you, what is cosine of 30? 30 degrees is represented by this line right here. In other words, they'll use theta a lot for the angle, and they'll say this is angle theta. And theta in this particular situation equals 30 degrees, which we've also known to write as pi over 6 radians if we're measuring in radians instead of degrees. And when they want an exact amount, you don't want to just put cosine of 30 into your calculator because it's going to give you a rounded off long version of what cosine of 30 is. So this is how you find exact values of cosine 30. So cosine 30 it's all about what the ordered pair represents. The ordered pair represents cosine comma sine. In other words, the x value represents the cosine, the y value represents the sine. So if they're wanting cosine of 30, you go to your ordered pair that was on your 30 degree spot and you pick the first of the coordinates for your cosine. So cosine of 30 actually equals square root of 3 over 2, and you just pick that right off the unit circle. So once you can draw a unit circle or create one, you can pick off whatever ordered pair you need to answer the question. And then sine, we could say sine of 30 degrees, but I'm going to change it up and use radians this time because it works for either one. And I'm going to say, what is sine of pi over 6 radians? So for sine, you go to the pi over 6, find that ordered pair, and the sine is the second one in the ordered pair, or the y value, or the y coordinate. And so we want to use 1/2 for sine of pi over 6. So the answer is 1/2 for sine of pi over 6. Then if you need tangent, tangent is just the y1 over the x1. And so basically the sine over the cosine. And so if you can remember to put the second one over the first one, that will get you tan of that spot. And so tan of 30 degrees, going back to degrees, is 1/2, let's write it over to the side, 1/2 over square root of 3 over 2, because that's sine over cosine, or the second one over the first one. And then there's a rule with fractions that you can, if you're dividing by a fraction, you can multiply by the reciprocal of that. And so I'm going to show you a shortcut in a minute, but let's do the long version. So dividing by square root of 3 over 2 is the same as multiplying by its reciprocal. So we can take it off of the bottom and move it to a multiply by the flip of it. And so what happens is the 2's cancel and you just end up with 1 over the square root of 3. Rationalizing that, if necessary, most of the time we try to rationalize it, means multiply top and bottom by square root of 3, and across the top you get square root of 3. Across the bottom you get square root of 9, which is just a plain 3. So we're going to call tan 30 square root of 3 over 3. Now one thing you can do is to at least shortcut this step here is if the denominators, if you have two fractions, a fraction divided by a fraction, and the denominators are the same, you can just kind of scratch them off and that will be your answer. That's my shortcut. It's 1 over square root of 3. Now you still may need to do the rationalization step down here, but at least that cuts out this flipping and having to flip and multiply, because if the denominators are the same, then, and the denominators will always be the same on these because they're all over 2, including the 45s. Those were square root of 2 over 2. So all the 45s and all the 30s and all the 60s will always be over 2. So when you put one over the other one, the 2's will cancel and you'll just be left with whatever is there when you scratch off the 2's. So that's a shortcut. So then if we do secant, if we go back to radians, secant of pi over 6, if you look over here, it says that secant is just the flip of cosine. So if cosine is the first one, and we flip it, we end up with 2 over the square root of 3. Now you might be able to leave it like that, or you might have to rationalize it, which just means you'll do top and bottom by that radical, and you'll get 2 square root of 3 over square root of 3 times square root of 3 is square root of 9, which is a 3. And so I'm going to write it like that, rationalized. So it's 2 square root of 3 over 3. That is secant of pi over 6 radians. Then we'll go to the next one, cosecant. Cosecant, 30 degrees. Cosecant is the flip of the sine. So you just go find the sine, which is the second one, and you flip it over. And that would be 2 over 1, which is just 2. So I'm going to write just 2 for that one. And then finally, cotangent of pi over 6. Cotangent is the flip of tangent, but sometimes since you only have cosine and sine in your ordered pair, it's easier just to think of cotangent. You put the cosine over the sine. So the first one over the second one, which is the reverse of the way we did it with tangent. So cotangent is cosine over sine. If you remember, if it has a the co is on top, if that helps you. And so we want to put, I'll come over here and do it. If we want to put the cosine of that particular point over the sine of that particular point, and remember just a minute ago I said if you just scratch off the matching denominators, so this one has a 2 denominator and this one has a 2 denominator, so I can scratch them off, we end up with square root of 3 over 1, and square root of 3 over 1 is just square root of 3. So with this one single ordered pair, we were able to create all 6 trig functions using some combination of those ordered pairs numbers. And so that is just one example of how you can do it. Let me show you how to go outside of the 30 into any other quadrant and how you can quickly create those as well. I wanted to point out that you don't always have to draw the entire unit circle to find one thing like what is sine of 210. When you want the exact value of sine of 210, you can create part of a unit circle, and once you get good at the unit circle, this will start to make more and more sense. And so what you want to do is, when I see sine of 210, I just draw a quick x and y axis, and then I think, where is 210 going to fall? So we know that 180 is halfway around, and so we need to go a little farther than that, and specifically we need to go 30 degrees farther than that. So we go 30 degrees farther than 180, which is here, and that gives us 210. Then once you know where you are, you can list what is the ordered pair of that dot. Well, if you think about it, any 30s and 60s are always the pair of numbers 1/2 and square root of 3 over 2 in some combination and in some order. And so since this has to do with a 30, we are going to go long, short, and just see what that produces. And so the ordered pair would be the x value is a negative of the long number, and the y value is also negative of the short number. So it's a long, short, negative, negative. Once we have that, we can go back up here and say, okay, which one represents sine? Well, we said that the second one represents sine, and so our answer is negative 1/2, and we're done. So that's how easy it can be to create part of the unit circle and think through what numbers are involved. The 30s and the 60s, any combination of 30s and 60s have these two numbers involved, and anything with the 45s have square root of 2 over 2 involved. And so on the same problem, if I wanted to find sine of, let's say, right down the middle here, so say we were asked to find sine of 135. 135 is 45 degrees before 180, or you can think of it as 45 degrees after 90 degrees. Either way, it involves a 45. It's the one right down the middle of the quadrant. And a 45 will always involve these numbers, and so we do the ordered pair here is going to be a combination of square root of 2 over 2 on both of them, and the x value is negative, the y value is positive, so make a negative on the x value. Now you're ready to answer the question. Sine of 135 is always the second one, and so we have square root of 2 over 2. So these are our answers to these two questions using part of the unit circle, just a quick sketch. There's one more example on the next page. When they ask for it in radians, it can be just a little bit harder, and so I wanted to give you a trick for that. When the denominator of a radians problem is 3 or 6, that means that it's going to be the 30 degree or 60 degree kind. In other words, our numbers that are going to be involved are going to be 1/2 and square root of 3 over 2, some combination of those two numbers when it ends in a 3 or a 6 on the bottom, the denominator. And then if it has a denominator of 4, then you're talking about it being a 45 degree angle. It'll be right in the middle of a quadrant, and the key number there is going to be a pair of square root of 2 over 2's. And so that should help you keep that straight. If it ever has a bottom or a denominator of 2, like pi over 2, remember the 2's were always at kind of our 4 key spots. You had your pi over 2 here and your 3 pi over 2 here. Those are the only ones that'll have 2 on the bottom. And so you know you're at one of these two spots, which means your ordered pair is either 0, 1 or 0, -1. And so that's how you can deal with a denominator of 2. So that's a quick overview of the denominators and what you're looking for. And so let's sketch this one real quick and think, okay, this has a denominator of 3, but we don't have denominators of 3 right off the bat. What we had is 6. So remember, this was 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, and then back to 12 pi over 6. So I didn't write the whole thing, but just to give you a count real quick, that's how you go around the circle in 6. So we could get the 5 pi over 3 to become 6 if we, over 3, if we multiply the bottom by 2 and the top by 2. That's just an equivalent fraction that's equal to the same thing as 5 pi over 3, but we're going to call it 10 pi over 6, because that would reduce to 5 pi over 3 anyways. So we're looking for the 10 pi over 6, which is right here at the 10 spot. 10 pi over 6 is there, which is the same as 5 pi over 3. And the ordered pair for that spot, you'd think, where is this dot? The dot is a short, long, which puts our ordered pair in red here, and secant is the flip of cosine, so you will use the cosine in its flipped over form, which is 2/1 or 2. So that's our answer.